This is the Chapter 7 study guide. So we want to simplify this expression. We're going to divide these polynomials here by subtracting the powers. There's only one r, so carry that. And then for the t, I'm going to do this on the side. Take the negative 7 and subtract 5, and that means you actually get t to the negative 12. So you could write it like this, but we don't leave negative exponents, so it's actually r cubed over t to the 12 is your solution there. The other option was you could from the start note that, okay, t to the negative 7 is actually a t to the positive 7 on the bottom. And so you still get a t to the 12 on the bottom. That's number one. For number two, since I have a negative power means you have a reciprocal. So I'm going to take this thing before I distribute that power. I'm going to flip the entire quantity here, so negative exponent means reciprocal, so I flipped all this. Now I'm going to distribute this fourth power. The m gets it, the 5 gets it, and the a third gets it. So we get 5 to the fourth. M, this is really an m to the first, so if you take 1 times 4, you get 4. And then this is an a to the third. 3 times 4 is 12. So you get a to the 12. Now this is the answer in exponential form. But if you have a calculator accessible to you, or you could even just do this by hand. 5 to the fourth power that's 25 times 25. So again, you could just run this in your calculator if you don't want to do the arithmetic by hand. But you could do 5 caret 4, and you should get 625 if you do that. So you get 625 m to the fourth over a to the 12th power. And that's the answer for number 2. For number 3, we want to, again, since we're multiplying, you add the powers. I'm going to reorder this to a more convenient way. So I'm going to put the c to the third first, then the c to the negative 1. Now, c to the 0, anything to the 0 power is 1, so I'm going to cross that out. That's just multiplying by 1. When you multiply by 1, you don't really do anything. And then there's a v to the ninth here. I can add these powers. 3 and a negative 1 make a 2. So c squared v to the ninth is your final answer, and that's the answer for number 3. For number 4, we have to do the exponent, raising a power to a power rule, and also multiplying. So you're going to have to add and multiply simultaneously here. I'm going to rewrite this first thing, 2y to the 3/4 times, and this is h squared. Now, before I can write these, I got to distribute this exponent of 6 to each term that's in the parentheses here. These are all connected by multiplication, so they each kind of get that 6 power. So I get 2 to the 6 power. Then I get y to the 1/3, and that's raised to the 6 power. Shortcut is to multiply the exponents. And I get h to the negative 4th, and that's raised to the 6 power. So I have to multiply those exponents. So first I get h to the negative 24. I'm going to work my way back the front. This is 6 times 1/3. If you need to do this, 6 over 1 times 1 over 3. You can also multiply in your calculator, but you just cancel this out and you get 2, so that's y squared. In case you forgot how to multiply fractions in your calculator, because I mean it's a good skill to know. You could do 1/3 times 6 like that, or if you want to do alpha y equals, and then you do 1 over 3 like this, and then times 6. So either way, you could do that. But that's easy to multiply by hand. Now, 2 to the 6, you could do that mentally using mental math. You could just keep doubling a number and doubling a number, write 6 of them. This is 4, 8, 16, 32, 64. Or if you want, you could do 4 times 4 times 4. Either way, you get 64 right there. There's no need to leave it in exponential form. Then we take this h squared, and we're going to end up combining it with that h over there. And the y to the 3/4 here, we're going to combine it with this y over here. And then this is a 2 right here. So 2 times 64. Multiply those together, you get 128. Y 3/4, a y2. I'd rather write it in fraction form. If I add 2 over 1 plus 3 over 4. Again, this is something I can do in my calculator. or I can use common denominators. I get 11 fourths if I use common denominators. In your calculator, you can do 2 over 1 plus 3 over 4. And yeah, it gives you a decimal, but to convert it to a fraction, math enter. So either way, you get 11 fourths. So the y is to the 11 fourths power. The h, we got a 2 here. We got a negative 28. If you add 2, negative 24. If you add 2 and negative 24, you get negative 22. So h is to the negative 22. We don't like to leave negative exponents in our final answer. So that's going to go on the bottom. So you get 128 y to the 11 fourths all over h to the 22nd power, like so. Another way you could write this, if you don't like fractional exponents and proper fractions, you could also take that y and you could do like the 11th power and you could fourth root it. But that would imply us like simplifying a little more and using like the little radical rule. But there's really no reason to write it that way since we were given the stuff in exponential form. It makes sense to write it in exponential form anyway. And if we did put it in radical form, you could simplify this further because if you fourth root y to the 11th, there's two sets of 4 inside an 11. So if you were going to write it in radical form, you would actually pull out a couple y's here. So you would get y on the fourth root of, and then there's 3y stuck inside because there's a remainder of 3. So 2 y's get out, remainder of 3, and that's over h to the 22. But you could just leave it in exponential form. That would be it in radical form. But again, don't worry about this. Is something you'll simplify more often in algebra 2. Just leave it in exponential form. That's the answer for number 4. For number 5, notice how we have two bases, the same base, and they're raised different exponents. So we could think of this as x to the 5th times x to the negative 2, which would give you, that's x to the 3rd. So this is whatever your base is, that's the base to the 3rd power. So there's your answer in exponential form. And if you want to calculate what that is, 1.2 to the 3rd power, you get 1.728. Now you could just, when it's a number, you could just enter this in your calculator from the get-go. But it's quicker to do the shortcut rules. If we raise this to the 5th and we take that same base and then we raise it to the negative 2nd, you should get the same answer either way. But really, it's good practice for same base. You take the powers. If you're multiplying, you add the powers. If we were dividing, you subtract the powers. That's the answer. This is the exponential form answer. But you have access to a calculator. This is the simplified form for number 5. For number 6, we're raising up something with a power to a power. But for like the 27, like you got to distribute that power to both things in the parentheses because they're connected by multiplication. So if you remember, if you look at order of operations, just like multiplication and division distribute over addition and subtraction, exponents distribute over multiplication and division. So we have the 27 to the 1/3, and we'll take care of that. And then we have q to the 1/2 to the 1/3. And the shortcut when you're raising a power to a power, you multiply the exponent. So that's q to the 1/6. And 27 to the 1/3, well, if you remember what a 1/3 power is, that's a cube root. Cube root of 27 is 3, because 3 times 3 times 3 is 3 times 3 times 3 is 27. So the answer is 3q to the 1/6. Now, you don't have to concern yourself with this, but another way you could write this, since it's given in exponential form, I would leave it in exponential form. You could also write the 1/6 power as a 6th root of q, but just leave it in exponential form. There's no need to convert it to radical form since the directions say to do that. That's the answer for number 6. Now, number 7, they do specifically say put it in radical form. And remember, this is a radical. That's a square root. That's a cube root. You can have a 4th root, 5th root. It keeps going up. In statistics, we use higher roots like In statistics, you sometimes use the 23rd root for certain things. But this is a radical sign, and if there's a 3 or a 4 here, it's fourth root. If there's no root there, it's understood to be a square root. But what is a 1/2 power? Well, you should remember that something to the 1/2 power is square root of that thing. If you have something to the 1/3 power, that's cube root of that thing. So, but what we don't have x, just an x inside there. We have a 4 and an x, and that's inside of a square root there. So it's square root of 4x. So that's the expression in radical form. Now, we can actually simplify this radical. This is square root of 4. This is square root of x. So remember you have two radicals, so you could simplify that a little bit better. Since square root of 4 is 2, this is, if you did simplified radical form, it would be 2 square root of x. But there's your answer right there, square root of 4x, and this is that thing simplified. For number 8, we're asked to do pretty much the opposite of what we did in number 7. We want to go from radical form to exponential form. When they say rational exponent, rational essentially means write it as a fraction. So they don't want you to, you could write it as a decimal, but let's stick with fractions. So in general, remember this rule, x to the m over n is equal to x to the m inside an nth root. So if you apply that rule here, well, we have the a is to the 4th power, and it's fifth rooted. So if you write that as a rational exponent, you have a, the m right here is like what the 4 is, and the index of that radical is like what the n is. So that's fifth rooted here. So it's a to the 4/5 power. You could technically write a to the, if you take 4 and divide it by 5, you get 0.8, but leave it in as a fraction because it's easier to see the relation. If you write 0.8, it's like, wait, where the, zero point 0.8, how does that relate to a 4 or a 5? It's 4 divided by 5, but you lose the connection there. So leave it as a fractional exponent. So when they say rational exponent, think fractional exponent. That's the answer for number 8. For number 9, I actually want us to focus on explicit sequences. Now, I will write the recursive formula, but on your test, I want you, explicit definitions they're just a lot better because they lead us into functions. So if you want to do recursive, if you'd like to learn what it is, there may be, say, a bonus on the test about recursive sequences. That's great, but explicit is the thing you should focus on. In recursive, here's how it works. You write whatever the first term is, and then you talk about how to get the next, like how to get the nth term. Now, the first term is your a sub 1. So a sub 1 is equal to 10. Well, how are we getting from one term to the next? Well, we're multiplying by a certain number. That number we're multiplying by is 4 each time. So to get the nth term, so like think about to get the, let's walk it through slowly. To get the second term, you take the first term and you multiply by 4. To get the, I'm putting that's a little 2 there. To get the third term, you take, well, this is 40, right? And you multiply by 4. To get the fourth term, you take the third term, which is 160, and you multiply by 4. So in general, this is your first term, and then you say to get the nth term, right? You take the n minus 1 term. So, this is the second term, that's the first term, third, that's the second term, fourth, that's the third term. Oh, forgot the 0 there on the 160. So you take the previous term and you multiply by 4. Now that's the recursive way to do it, but here's how you can see the connection really easily for explicit. So instead of writing for this is 10 times 4, right? Well, notice how this 40, I'm going to write this 40 a different way. That's 10 times 4, that's like the 40. And then there's times another 4. And then what is this 160? Well, that 160 is 10 times 4 times 4 times 4, which is what this, like this, if you take 4 times 4, that's 16, times 10 is 160. And notice how if you want to get the fifth term, yes, it's you take 640 and you'd multiply it by 4, but what is that 640? That 640 is a 10 times a 4 times a 4 times a 4. That's what 640 is, these numbers right here. And then this 4 is you're multiplying it by 1 more. That's how you get the next term. So the pattern for explicit is for the third term, you multiply 10 by 2 fours. For the fourth term, you multiply 10 by 3 fours. It's 4 to the third. For the fifth term, notice how there's 4 fours. So for the explicit term, this is 10 times 4 squared for the second. For the fourth term, you do 3 fours, 4 to the third. For the fifth term, you do 4 fours, 4 to the fourth. So in general, even though this is the recursive formula right here, I want you to know the explicit formula for the test. And the general form is this. To get the nth term, you take the first term and you multiply it by whatever your common ratio is, like in this case, the 4, to the power of 1 less than whatever sequence, whatever term in the sequence you're looking for. So since we're looking for say we were looking for the eighth term, you'd raise it to the seventh power, 8 minus 1 is 7. So the explicit formula for this is a sub n is equal to the first term is 1, the common ratio, that r is 4, and we raise that to the power of n minus 1. That's the general formula to get each term of the sequence. That's the answer for number 9. For number 10, again, I'm going to do this a little faster. I don't want you to focus on recursive. I want you to actually be more familiar with explicit. But the recursive sequence would be this. The first term is 25, and to get the next term, you take the previous term and you multiply it by, let's see, what are we multiplying by? Well, it actually seems like we're dividing. Or if we're dividing by 5, that means we're really multiplying by 1/5. So your common ratio is going to be 1/5. So 1/5. There's your recursive sequence. Now, if we want to do, this is recursive. If we want to do explicit, which is what I want you to focus on for the test, to get the nth term, you take the first term, multiply it by the common ratio, which is 1/5, raised to the power of n minus 1. So there is the explicit formula for that geometric sequence. For number 11, we're multiplying numbers in scientific notation. I find it more convenient to multiply like those little, you call them, they behave like coefficients first. And then for the scientific notation, the tens, we know that they have a base of 10. So you can add the powers of 10. So this is times 10 to the 6th power. Now, what is 6 times 4.8? Let's calculate that. 6 times 4.8 is going to be 28.8. So you could write 28.8 times 10 to the 6th. But here's a problem with this. This is the correct, and the value is correct, but it's not in scientific notation. To get it in scientific notation, you have to have the decimal between the first and second number, basically. So the answer is actually 2.88 times 10 to the 7th. There's your answer, multiplying two numbers in scientific notation. For number 12, we're dividing two numbers. So just off on the side, I'm going to divide, again, those, I call them coefficients. So 1.5 divided by 5 is going to be 0.3. And then since we're dividing, we can subtract the powers. So for the 10, if I do 7 minus negative 2, be careful, you might be tempted to do 7 minus 2 is 5. But it's 7 minus negative 2, so it's actually times 10 to the 9th. Now, once again, even though this value is correct, in scientific notation, we want the decimal after like the first non-zero number. So we don't want the decimal after a 0. We shouldn't have 0.3. We should have 3.0. Now, unlike before, where since we were moving the decimal place, from the right side, like if we were moving the decimal place to the left before, so we added a power. Here we're moving the decimal place to the right, so you actually take away a power. So this is times 10 to the eighth, and that's that quantity. In scientific notation, the result you get from dividing these two numbers. You get 3 times 10 to the eighth. Now, you can do this in your calculator. If you put your mode in psi mode right here, you hit mode and you go there, it can do that, but you want to kind of take it out of that mode later. But honestly, it takes a long time to put in your calculator. Usually you want to be careful, use parentheses and dividing those things. Notice how fast I was able to do it just by hand. And also, here's the drawback of your calculator. You need to know that this E means times 10, and then the number after E means to the power. So even if you do it on your calculator, you have to translate from this notation with the E in it to, the way, human beings write it. So that's the drawback of depending on your calculator. But either way, the answer is 3 times 10 to the eighth, but you should write 3.0 times 10 to the eighth. You should not write 3E8 as your answer. I don't want to see this on the test. I want to see this right here. Okay, number 13 will be the last one on this first part of the study guide. So we want to use scientific notation to see how many red blood cells your body produces a day. Well, the body produces 2.2 times 10 to the 6 each second. So, but we need to figure out how many seconds there are on a day. Conversion fractions are a really easy way to do this. Sure, you can just kind of multiply and multiply over again, 60 seconds in a minute, 60 minutes in a second, times 24 and all that. But let me show you how to keep it organized. So there's 2 times 10 to the 6, and I'm going to write the units. Red blood cells per 1 second. Well, if I want to convert that, I know I need to multiply by 60 because there's 60 seconds. I'm just going to use S for seconds in 1 minute. But I don't know. That tells me how many blood cells per minute. There's also 60 minutes in each 1 hour. But that tells me how many blood cells per hour. Well, I know there's 24 hours in each 1 day. And if you notice, now I have red blood cells per day because all these other units end up canceling out. So if you take this value, multiply by 60 by 60 by 24, you can kind of do that intuitively, but using these little conversion fractions helps you see exactly how to get from one unit to another. And you can run that value in your calculator, and so you get, and I'm actually still in scientific notation mode, but you get 1.728 e to the 11, but I want to put that in scientific notation mode, like human language, with the times 10, not with the e. So I'm going to write this for part A. The answer is 1.728 times 10 to the 11th power. Now, for part B, we're told that 1 pint of blood contains about this number in scientific notation, blood cells. We want to know how many seconds it will take for your body to replace those lost by donating 1 pint of blood. So first they want you to say how many seconds it will take, and then they want you to tell them how many days it will take. So since 1 pint, if you look at 1 pint, is equivalent to this many blood cells, and we also know that your body produces this many blood cells each second, what we can do is we can figure out from this, we can figure out by dividing these two, we're dividing instead of multiplying, how many seconds it will take to replace this many. So there's this many cells in 1 pint. So instead of putting an equation like this, the reason I'm writing this way is this many cells is 1 pint, okay? And I know that your body in 1 second produces this many cells right here, 2 times 10 to the 6. You could have intuitively just seen that, oh well, we could have just divided right here. But the idea is like these cells and these cells cancel out. So that means to produce 1 pint of blood, we know it'll take, if you divide these numbers, that many seconds. So I divide the coefficients, 2.4 over 2. That's easy enough to do in my head. I can use a calculator, but it's easy to do in my head, 1.2. And then 10 to the 12th divided by 10 to the 6th, you subtract the exponents. So that's times 10. 12 minus 6 is 6. So it's 1.2 times 10 to the 6th. Don't forget units, seconds. And the same as before, I left off my units here. Let me make sure I write them. So this one was not seconds. This is the cells produced in 1 day for the previous answer. This is how many seconds it takes to replace the required that asked amount of cells. Now, to figure out the days, obviously, we know that if it takes a certain amount of seconds to do something, it should take a lot shorter time in days. So you can do these little conversion fractions here. And if you notice, we went from seconds to days. We multiplied by 60 and 60 and 24. The difference here is that now we're going to divide by 60 and 60 and 24. So a short way to do the second part of this answer, you take this answer, 1.2, times 10 to the 6, we're basically going to divide by 60 and another 60 and divide by 24. And you run that on your calculator and you get your answer. You can also multiply by the reciprocal of that. You can see it that way. So if you can see it as dividing by 60, then dividing by 60 and divided by 24. So this is your answer right here. And I'm just going to round off here. It's 1.3. Let's do 1.39. 1.39 times 10 to the first days. You could just do times 10. The one's optional, but I'm just going to leave it there because we're used to seeing an exponent in scientific notation, just to remind myself that I did not forget the units. And instead of SEC for seconds, honestly, that's fine if you abbreviate that way, but usually we just do S for seconds. So the first answer to part B is here. The second answer to part B, a much smaller number, is this many days. That's the end of part 1 of the study guide.